After discussing the common processing or tasks of two-dimensional arrays, now is the time to show you how to put these processings or tasks into practice. To do that, we would like to have the following example. In this example, we want to write a Java program that will read integer values and store them in two-dimensional array of size 5 rows by 4 columns. And we have already learned how to do that by writing nested loops. We process the array row by row. We read the data from the user as we visit every row. The second part of the question is asking to output the index of rows in which the sum of elements is equal to 100. For example, for row 0, if you add its elements 10 plus 10 plus 20 plus 60, it's equal to 100. So therefore, 0 is printed on the output screen. Now, if you go to row 1, if you add its elements 10 plus 10 plus 5 plus 2, it's equal to 27, which is not equal to 100. So therefore, 1 is not printed on the screen. For row 3, if you add the elements 10 plus 0 plus 0 plus 90, it's equal to 100. So therefore, 3 is printed on the output screen as the row number. So the output will print only those rows that have the sum of its elements is equal to 100. For any problem on two-dimensional arrays, if you want to find a solution for this problem, first ask yourself, to solve this problem, do we need to visit the array row by row or column by column? In this example, it says you need to find the sum of elements of each row. So that means we start with the first row, we add the elements, we find the sum, and we check for the sum. We go for the next row, we add the elements of this row, we find the sum, and we check for the sum. So we are visiting the array row by row. So therefore, to answer this question, we need to process the array row by row. So you write nested loops, you make the outer loop responsible for counting number of rows, and you write the inner loop responsible for counting number of columns. Let us go to JGrasp and show you how to implement this program. We are now in JGrasp. To read integer values and store them in two-dimensional array of size 5 rows by 4 columns, first we need to declare the array, and then we store the data inside this array. So we define it as integer with 2 dimensions, and we are going to call it array. And the number of rows is equal to 5, and the number of columns is equal to 4. Next is we ask the user to give us the data and store them into the array. Remember that to initialize two-dimensional array with input that is given from the user, we process the array row by row. So we use nested loops, the outer loop responsible for rows, the inner loop responsible for columns. So we write for integer row equals 0, row less than number of rows, so we write array.length row plus plus. Then we write the inner loop that is responsible for counting number of columns. So we write for integer col, which is short for columns, column less than array for row.length. And here we say column plus plus. In each iteration inside the column, we need to read the data from the user and store it into the corresponding index variable. So we write array row column equal to read dot next int. But to read the data from the user, we need to display a message to the user by typing the following. We tell the user enter integers for 5 rows and 4 columns. And then we ask the user to enter the data. To avoid confusion on which variable of the nested loops must be used for the row and column of the two-dimensional array, we recommend that you give the name row for the variable controlling the row loop and give the name column for the variable controlling the column loop, regardless the place of these loops, I mean inner loop or outer loop. Then use the name row for the row number and use the name column for the column number of the two-dimensional array. And that's why for the nested loop that we are using for reading the data into the two-dimensional array, the outer loop, the variable for this loop is given the name row because this loop is responsible for counting number of rows. And the inner loop, the variable controlling the loop, given the name column because it is responsible for counting number of columns. And therefore, we are using row as the first index, and we are using column as the second index. So follow this advice. This will avoid confusion on which variable to use as an indices to the two-dimensional array. So now we are done for the first part, reading the data and storing them into the two-dimensional array. Now we need to implement the second part by printing the row number if the sum of its element is equal to 100. As we discussed, we need to process the array row by row. So for integer row equals 0, row less than array dot length row plus plus, and the inner loop will be for integer col equal to 0, column is less than array of row dot length, and we have column plus plus. To find the sum of the elements for each row, we need a variable for summation. This variable must be initialized to 0 every time we visit a new row. So therefore, inside the outer loop, we will use a variable called sum, and we will initialize it to 0. And then inside the loop, the inner loop, we are going to add all elements in this row to this variable. So we write sum plus equal array row and column. This variable must be defined, so we are going to define it outside the loop, and we are going to give it initial value 0 just for not the compiler complaining that it was not initialized. After we find the summation and exit the loop, we will check for sum. If it's equal to 100, then we need to print the row number. So we write system.out.println, and the row number can be found in the variable row. But before printing, we are just printing row numbers, so we are just printing numbers. We need to print a message before printing any row number, and this message says the sum equals to 100 in row, and then we display the row number. Now the program is complete. We need to compile it and check that it does not have any errors, and we will run it for testing. We will first compile the program. Now it does not have any errors. Now let us run the program for testing. It is asking now to enter integers for 5 rows and 4 columns. Let us give it the following data. For the first row, 10, 10, 20, and 60. For the second row, 10, 10, 5, and 2. For the third row, 3, 50, 10, and 100. And for the fourth row, 10, 0, 0, 90, and the last row 55, 22, 54, 88, and as you see that it says that the sum equals to 100 in row 0 and 3. So this proves that the program is running correctly, and this is how we solve the problem and how we process two-dimensional arrays.